In the study of chemistry Form 4, we want to find the empirical formula for a certain molecules. So what are the steps to do that? First, we write the elements. Second, we write the respective masses below each element. Number 3, we divide each mass by the relative mass in order to get the number of mole. Number 4, we find the simplest ratio for all the numbers, and we should be able to get the empirical formula for the molecules. So let's try one example to understand that. Example 1. Find the empirical formula of the iron oxide produced when 44.8 gram of iron reacts with 19.2 gram of oxygen. The relative mass for iron is 56 and the relative mass for oxygen is 16. So the important points here is we need to identify the information given. This 44.8 is iron, and then 19.2 is oxygen. And we can use this, the relative mass, to calculate the number of mole. So let's look at this one. Iron, the color is a bit silver, that's why I use silver to write the word. So this is the mass, 44.8 gram, and oxygen is 19.2. So what we do is now we find the number of mole. We use 44.8 divided by 56. And this one, 19.2, we divide by 16. Doing this will give us the answer for 44.8 divided by 56, we should be able to get 0.8. And as for this one, 19.2 over 16, we should be able to get 1.2. So we want to divide it by smallest number. Among 0.8 and 1.2, 0.8 is actually smaller, so we use the original divided by smallest number, and this 1.2 divided by the smallest number, because comparing the two, 0.8 is the smallest. So doing this will give you the simplest ratio of 1, and this one is 1.5. But we do not want ratio to be in the form of 1 to 1.5. Instead, we want it to be in the form of 2 to 3. Because 1 times 2 and 1.5 times 2, you get 2 ratio 3. Okay, let's try example 2. Ribose is another sugar used by living cells to produce energy. It contains 40.0% carbon, 6.67% hydrogen, and 53.33% oxygen by mass. How many grams of carbon, hydrogen, and oxygen are in 100 gram of ribose? B. Get the empirical formula of ribose. So this is pretty straightforward. What we should do is we do this again. CHO. Based on the given information, we use percentage 40.0%, 6.67, 53.33. Based on this information, we realize that if you add up all the percentage, you should be able to get 100%. So we assume that there will be 100 gram of this element, so the exact mass will be 40.0 gram, 6.67 gram, 53.33 gram. You add up together, you get 100 gram. Okay, this is important because in question A they ask how many grams of carbon, hydrogen, and oxygen are in 100 gram of ribose. So now we have the answer for question A. Now we proceed. Remember the second step, we find the number of mole. Okay, 40.0 divided by the relative mass of carbon is 12. And then you have 6.67 divided by 1 because relative mass of hydrogen is 1. and then you have 53.33. You divide by 16 because the relative mass of oxygen is 16. So we want the smallest number. We get a number first. 40 divided by 12 will give you 3.33. Okay. 6.67 will be 6.67. And then 53.33 divided by 16, you should be able to get 3.33 as well. So looking at this, we get the simplest ratio. We divided by 3.33, and this one divided by 3.33, you should be able to get 2, and this is 121. So the empirical formula should be this: CH2O.